This is a follow-up video to a couple of other videos I did regarding this topic, the law of sines. So a lot of this stuff is covered in those videos. But just to refresh your memory here are the formulas for the law of sines. And we're using these to solve oblique triangles. That is, those triangles that do not have a right angle. They could have one obtuse angle, an angle larger than 90 degrees, or you could have three angles, all of them acute, less than 90. And again, keep in mind that the sum of all three angles of any triangle is always going to be equal to 180. Then law of cosines formulas, haven't done anything with those yet, but we went over these briefly. Here they are. And then those are the four cases that you have. Case 1 and 2, you're going to use the law of sines. Case 3 and 4, you use the law of cosines. And right now we're focusing on case 2, when you're given two sides and the angle opposite one of the sides. Side-side angle. So in the last video that I did on this topic, we were looking at these problems right here. Actually, you went over some discussion on different scenarios you could have, and I actually went through and worked out the first one. In this video, I'll work out the other two, because when you have the ambiguous case, which is what this is called, anytime you're given two sides of a triangle and the angle opposite one of those sides, you have the ambiguous case, which means you can have either one triangle possible, two triangles possible, or no triangle. So number one here is the one I've already done. So those are the answers we got. We were given that side A was equal to 3. And again, the sides are always lowercase and the angles are uppercase. And you want the orientation to write it down, draw a triangle in this orientation. So it's angle A is 50 degrees. And then you're given the side opposite that angle, A equal to 3. And then you're given another side, B equal to 2. That's the side opposite angle B. And you got angle C. And then side C, lowercase. And then when we solve a triangle, we simply solve for the missing sides, the lengths of the sides that are not given, and the measure of the angles that are not given. So this is what we got. But just to refresh your memory here on the different scenarios, anytime you're given this type of situation, if the side opposite angle A, in this case, and again, keep in mind these could be different depending on how they give it. So they could give you this, they could give you angle B and side B. But try to write it in this scenario here. So if it happens that A is greater than or equal to B, you're always going to have one solution. Don't have to worry about two triangles possible. You'll have one solution. And notice in this case, it's easy to check. A is 3 and B is 2. 3 is greater than or equal to 2. So this one, of course, we had one triangle, and these were the missing parts of that triangle. Now, if I draw a perpendicular from side C to the opposite side, that's the altitude of this triangle. And of course, I can find the length of this altitude by just taking the sine. I can label this as h, for example. And then say the sine of angle A, which is 50 degrees. Sine of 50 degrees is h over 2. And then solve for h. And I get this length right here. So if it turns out that this side right here is smaller than h, the length of side A is smaller than h, then you're going to have no solution, because you can't form a triangle. Let's say instead of 3 it was 2. Not long enough to reach the other side. So in that case, there's no triangle possible. Now the situation when A is larger than h but less than the other side too, so it's kind of in between side B and the altitude, then there's a possibility you could have two triangles. And I went over that in detail in the other video, so I'm not going to go into much here. Otherwise, this video will be too long. But I'm just going to clear this here. So again, we're going through the different scenarios. Let's read the instructions again. Determine whether the given information results in one triangle, two triangles, or no triangle at all. So in other words, you have no solution. Solve any triangles that result. Okay, one resulted in one triangle, and that's the one I did in the last video. And I will go ahead and leave some links to those two videos in the video description, just in case you missed them or want to refer to those. There'll be links to those videos in the video description. So let's go to the second problem here. Okay, so in example 2, problem 2, we're given that angle A is 60 degrees. So I'm drawing the triangle over here. And I can keep in mind that the drawing here is not to scale, okay? It's just to give me something to look at. So angle A is 60 degrees, and the side opposite angle A has a measure of 4 units, so A is equal to 4. And then the other side is 5 units, so B is equal to 5. And then the angle opposite that would be angle B over here. And then we got angle C, and then the side opposite that is lowercase c. So what's missing here is angle B. I have it over here on the left. Angle C is missing, and side C is missing. Notice that in this one here, I'm not guaranteed that I have a solution like in problem 1, because I said that if the side opposite angle A is greater than or equal to the other given side, in this case 5, you have one solution for sure. Well, 4 is not greater than 5, so I'm not guaranteed that there is a solution. Now I could go ahead and find the measure of this altitude, and if 4 is less than that, then I know I can't have a triangle. But if you follow these procedures, you don't have to go through that. So I'm just going to assume that I have a solution, and I'm going to say, well, let's try to find angle B. So I'm going to say the sine of angle B. So I'm going using the law of sines over the opposite side, the length of the opposite side, that would be 5, should equal to the sine of any other angle that's given. Okay, so 60 degrees is given, so I have the sine of 60 degrees over the length of the opposite side. So the side opposite angle A is 4. So now I solve for B. So I can do this, and I can say I'm going to multiply both sides by 5 here. So those would cancel here, and that puts the 5 over here. So then if I take the sine inverse of both sides, on the left side I'll have B by itself. So B then should equal to sine inverse. So taking the sine inverse of both sides, on the left side, I'm left with just B. That's after multiplying by 5. So this will be sine inverse of, this will be 5 sine of 60 degrees and I should have a 5 here. 5 times the sine of 60 degrees over 4. Okay, so B should equal to sine inverse of, this is 5 times, or 5 sine of 60 degrees over 4. So let's go ahead and compute that in the calculator. So I get my second key and then sine inverse. Get the sine inverse. And this should be 5 sine 60 degrees. Now notice I'm not putting the degree there because I have my calculator in degree mode. So always make sure that if you're dealing with degrees, you have your calculator set to degree mode. So if I hit mode, you see that's in degrees. So I have it typed in then, sine inverse of 5 sine 60 divided by 4, and hit enter. And it gives me an error. Now what this simply means is no triangle can be formed from this data. If I were to compute the length of this altitude right here, it would be 4.3. 4.3. Side A is 4. It's less than the altitude. So if I try to form a triangle, this side right here is never going to hit this space. So there's no solution. Now another way I can do this without even computing the altitude, I can just look at this part right here. Just compute this. Sine of b is equal to 5 sine 60 over 4. So let's look at that. This will be 5 then sine. Notice it's not inverse here. I'm just computing the value of this right side here. Sine of 60 degrees divided by 4. And that gives me 1.08. That's not possible. The sine of any angle, that's based on your domains from the sine, and also the cosine. Actually, cosine of any angle and the sine of any angle is always the value between -1 and 1. So this, from here, I can just say, well, the sine of angle B comes out to 1.08. So this one has no triangle. No triangle possible, or no solution. Or 0 triangles. Okay, another way to say it. So number 1 was the case where we had 1 triangle possible. I solved that last video. And in this one here, I have no solution, no triangle possible. To this, let's look at example 3 here. I'm given that side B is equal to 2, side C is equal to 3, and angle B is equal to 40 degrees. So here's my diagram. Lettering is different here, but the same kind of setup. If this value for B were larger than 3, then I would know for sure that I have one solution. It would be kind of like number 1. If it turns out that B is somewhere between the length of the altitude and the length of the other side, in this case 3, then that's the case where I could have 2 triangles possible. And I can verify that. So now what we'll do here is just assume that we're going to have one solution. And if we get a contradiction, like we did in the problem 2, then it has no triangle possible. Or we could have 2. And you can see by the setup that I have here, we're going to have 2 triangles. So this is what we'll do. I have sine I'm going to try to find C first, angle C. So I'm going to say the sine of C over the length of the opposite side. which is 3, should equal to the sine of any other angle that we know, and we know 40 degrees is angle B, so let's just say sine of 40 degrees over the length of the opposite side, which is 2. Okay, so now let's get the calculator. So sine of C is going to equal to, I'm going to multiply both sides by 3, so this will just be 3 sine of 40 over 2. And I want angle C, so I want the inverse. So C will equal to sine inverse of, let's put 3 sine of 40, close parentheses there, divide by 2, and close parentheses, hit enter, and I get C is equal to 74.6 degrees. Run that out to one place, 74.6 degrees. So let's go ahead and write this out here. Now for right now, I'm assuming that we have 2 triangles possible. And we can confirm that we do or we don't. You'll see with the steps that I go through. So if we have 2 triangles possible, they can't be both C. So I'm going to label one C1 and the other one C2, if there isn't a second one. So 74.6 degrees is one triangle possible. In the discussions from the earlier video, we said that if you have compute the sine of a acute angle, let's say sine of theta is equal to some number, then sine of 180 minus theta is also equal to that number. So what you do is subtract 74.6 from 180. So 180 minus 74.6. And we get 105.4. Can we form a triangle with this? Because if you take the sine of 105.4 and the sine of 74.6, you get the same number. So that means those 2 angles could be angles of this triangle. So let's do this. Let's assume that we have second triangle. If we do, then angle C, which in this case would be C2, corresponding to the second triangle, 105.4 degrees. And all you would have to do is say, okay, 105.4 degrees. The given angle, see, notice side C equal to 3. That's going to stay. That's given. Angle B is 40 degrees. That's given. We need to find the missing parts. So now we're saying 105. Can 105.4 be an angle of this triangle? Well, we got 40. And 105.4 plus 40 is not over 180. And that's what happens if you add this angle to the given angle and you get more than 180, then you can't form the triangle because the 3 angles have to add up to 180. So in this case, it works. We have 2 triangles possible. You can always confirm if the angles are going to work with the triangle you have. So now what do we have to do here? Now we have to find angle A. So angle A, in this case A1, So keep in mind, this is triangle 1. This is triangle 1. And over here, this is triangle 2. So for triangle 1, we confirmed that C1 is 74.6. We're given B to be 40 degrees. So all you have to do then to find the third angle, which is in this case A1, is add the 74.6 and the 40, subtract it from 180, and we get A1, angle A1 to be 65.4 degrees. Now what do we need? We need A. In this case it's A1. So I'll just do it here. I have A1 divided by the sine. Of the opposite angle. So this would be sine. And of course we found that over here, 65.4 degrees. And then this is going to equal to, just take any other ratio that works. Well, we have 2. I'm going to take the information given. Side B is 2. And the sine of the opposite angle, that's the sine at 40 degrees. So then, multiplying both sides by the sine of 45.4 degrees, A1 is going to equal to 2. I'm doing this, multiplying both sides by sine of 65. I will put it over here and cancel it on this side. So it would be 2 sine of 65.4 40 degrees. And on the triangle over here, this is divided by the sine of 40 degrees. So I get that A1 is 2.83. Run that out to two places, 2.83. So let me clear this. It's 2.83. Now we go to the other side. So now for the second triangle, C2 is 105.4, as we found out earlier, and we're missing side angle A. In this case is A2. So again, we have two angles now. The given angle is 40. So B is 40 degrees, and C, or in this case C2, is 105.4. So add the 40 and the 105.4, 40 plus 105.4, subtract that value from 180. And we get this angle A, or A sub 2, is 34.6 degrees. So now we need side A, which in this case is A2. So we just have A2 divided by the sine of the opposite angle, which we just found to be 34.6 34.6 degrees. And then the ratio on the other side, again, has to be consistent. So I have to have the length of the side up here. So I'll use the same one I used previously. 2 be equal to 2, and then the sine of the opposite angle, that's 40 degrees, so that's to be the sine. $40. So again, you multiply both sides by the sine at 34.6. So on your calculator, just say 2 times the sine of 34.6 divided by the sine of 40. So 2 times the sine of 34.6 divided by the sine of 40. And this should come out to the two places 1.77. So that completes the video. We do have some more solving of oblique triangles using the law of cosines later on. Also a few applications and a variety of other videos in technology. Thanks for watching. We'll see you next time.